And that next presentation is Casting a Fishing Net for SUSHI Data. It's presented by Laura Beane and Maureen Day from Kennesaw State University. Laura Beane is the Data Services Librarian at Kennesaw State University. She has an MS in Library Science from East Carolina University. Her professional experience includes data analytics, research, web services, and data services librarianship. Marie Day is a systems librarian and librarian assistant professor at Kennesaw State University. She received her master's in library and information science from Valdosta State University. Her professional experience includes setting up, maintaining, and troubleshooting library systems. Thank you both for being here. As soon as you're ready, feel free to share your slides and take it away.
Thank you so much. We're really glad to be here from sunny Marietta in Kennesaw, Georgia, northwest of Atlanta. After a few days of cold rain and fog, the temperature is dropping below freezing tonight, so that's about normal for now. Thank you for joining us, and our topic is managing our SUSHI data in Alma, our library services platform. So for any of you unfamiliar with the non-seafood sushi, it's an automatic harvesting protocol to bring standard usage reports from vendors into Alma, so we can report on them in Alma Analytics. It took us several months to implement SUSHI. We went down our vendor list to determine which ones offered it. We sorted through conflicting instructions, found various links, and requested secret codes, and it was thrilling. It was exasperating. But in the end, when we were done, I was the one to write new reports for national statistics. So now I had the exact fields suggested in the ACRL definition. Cool. So writing the report was fairly simple, straightforward. Things were going great. And then I hand it to our assessment librarian, and she says, how come Oxford Journals is 0? I know I read some there. I think I downloaded some. Oops. So I solved the immediate problem. Of course, I went and reconfigured that account, but what about next year? What about after that? Because something's going to go wrong sometime. So I started wondering, what strategy could we implement to prevent this kind of problem in the future? Not my field of expertise. I just started debating, what could we do? Are we going to have to compare numbers from every report from every single SUSHI account in Alma, over 50, to numbers on every single vendor's admin site? We don't have time for that. I know y'all don't have time for that either. But fortunately, by that time, my colleague Laura had joined our team, and with her background as a data analyst, she designed a method to help us focus our maintenance efforts. So I'm very excited for her to take it through that today, step by step.
Thank you, Marie. So like Marie was already saying, we really needed a method for finding those inconsistencies in our SUSHI data. And the way I went about that was by finding outliers. So we define outliers in this case as data points that differ significantly from others in the data set. And often you'll be able to look at your data and say, oh, wow, there was a lot of usage that month, and that doesn't look quite right. But when we have so many vendors and so many data points, that's almost impossible to do across the board on a regular basis. So what we're doing here is just helping ourselves with a little bit of automation, which I'm going to cover later in the presentation on exactly how to do this. But by finding outliers in our SUSHI data, it helps us investigate only those platforms that seem to have an atypical data point, instead of having to check each platform individually, and it saves us a ton of time. So next I'm going to go into the how we did this. And after Marie pulls those reports in Alma Analytics, I export the data into Excel to perform more complex data analysis. And to begin identifying outliers, there are just a few different data points that need to be calculated. So here they all are listed out, the ones we really need. And the first I'm listing isn't really a calculation. It's the field that comes from our report that Marie pulls in Alma. And it is the counter usage data point. And it's really the most important data point because it's what we're going to calculate everything off of. And it's the data point that we're going to say whether or not is this an outlier or it's not. Then second, we need average by platform. And this is the average of that counter data point by each individual platform or vendor. And we need to calculate it by that group so that we're comparing just that vendor's data to itself instead of all of the counter data across the whole sheet. The next step, we need standard deviation. And standard deviation is the measure of variation of a set of values. It calculates the variation of the group as a whole, which again is why we needed the average for the group. But along with standard deviation, there are a few other functions that are needed to calculate in the sheet, and that is difference from average, difference squared, and variance. And those three are all needed to bring us to standard deviation. But once we do have that standard deviation, then we can calculate our upper and lower limits. And in statistics, these are the values that define our outliers. For example, if the data point is above the upper limit, it's an outlier. And similarly, if it's below the lower limit, also an outlier. So I like to say the limits are the normal range. So anything within the upper and lower limit is within a normal range. And then finally, that leads us to our last calculation, which is the outlier. And again, that is just a data point that falls outside of that normal range. So now I've gone through all of these definitions and what data points we'll need. Let's take a quick look at the sheet. So this is a screenshot directly from the Excel sheet that I use to calculate outliers. And you can see here I filtered for just one platform, so it's a little bit easier to look at, and in this case being Credo Search. You can also see in the next two columns, I'm pulling year and month, which is our data range, date range. And I'm also pulling about 1.5 years worth of data. And it's important to note here that the amount of data that you pull is really important because too little data over a short period of time could really skew your results. For example, if I pull data from just 4 months over the summer, for example, it could look quite low because we have quite a few less students on campus. And if May was included in that, when we do have a high volume of students, it could look like an outlier, when in reality, it's probably a pretty normal number for a research period. Additionally, in this example, you can see in column H, that's where my counter data point is held. And I'm using the Counter 5 TRB1 report, which is the books report. But this works with any of the SUSHI reports. The same method would work to find outliers. And then finally, like we talked about in the previous definition slide, you can see from column I to P, all of the same functions that we're going to need to calculate to finally find our outlier. But this is the basic layout of the sheet and kind of how it functions. You can see here in orange, there was an outlier identified. So it might be a platform we'd like to investigate. But next, I'm really going to get into the meat and potatoes of this whole process, which is the formulas that I use to build this out. And this may be very complicated and statistics heavy, especially for people who are not as familiar with Excel. But I find that it's really worth going through to calculate all of these points manually. And I'm going to show you exactly how I did it. And another thing to note is that Excel does have a standard deviation function, which makes things very easy. However, I find that it works best when you're working with the whole sheet of data and not when you're trying to compare individual groups like we are here with vendors, which is why, again, I did all of this manually and all of these different functions. But let's go ahead and jump into our very first calculation, which is average by platform. So you can see here in column I, each individual data point is turned into an average for Credo. So it's basically just saying, if column A equals itself, so we're just looking for groups, then average everything in column H. So that's our very first calculation. The next step, we've got difference from the average. And this is just asking how our original data point differs from that average we just calculated. The next function we need is that difference squared. So the difference in column J times itself. And then that brings us all back together to find our variance. And variance, again, is just another average if function. So saying if the group as a whole equals the group, then instead of finding the average of all of the counter data, we just want to find the average of the difference squared. And all of this is to say, if anyone remembers back to their very old statistics class, standard deviation is just the square root of that variance. So all of these functions kind of lead us into our standard deviation. And again, once we find that standard deviation for the group, we're ready to calculate those limits. So first up, we've got our upper limit, which takes the average that we calculated in the beginning, plus the standard deviation, which again is the measure of variation in the sheet. However, you're going to notice here, I'm multiplying that standard deviation by 3. So why do we do this? This is basically the empirical rule in statistics, which just states that 99.7% of data occurs within 3 standard deviations of the mean within a normal distribution. So anything above those 3 standard deviations falls outside of that normal distribution, hence making it an outlier. So that's why we multiply it by 3 there. And next up, we've got our lower limit, which is the exact same function with one small difference. We are taking away the standard deviation times 3 from our average. And then again, that is just because it is our lower limit. And one thing to notice here is that our lower limit is calculating in the negative. But if we're thinking about this logically, our counter usage cannot be below 0. But I just kept it here for this purpose because we're simply trying to identify outliers. And in the case of 0, it isn't abnormal for something to have a very low usage. So we're good to go with keeping these negative numbers. And then finally, after all of this, we've got our limits, the moment we've all been waiting for, the outlier. And I know this calculation looks really long, but it's quite simple once you get the hang of it. Basically, I'm going to go into the middle of the function and work our way out to understand what it's saying. So you can see here, it's saying if column H is greater than N, so if our counter usage is greater than our upper limit, call it an outlier. And same thing, if column H is less than O, if our counter usage is lower than our lower limit, also call it an outlier. And finally, on the very end of this function, we've got if in A. So that accounts for all of those that aren't identified as outliers in the middle. If it's not identified as an outlier, we just want to leave it blank. And that is all this function is doing. And you can see it down the column working out pretty well that way. So everything that's not identified as an outlier is totally blank. And it says very clearly which is identified as an outlier. And you can look back at column H and see that the value here is 121, which is higher than our upper limit, 96.7. And one important thing to keep in mind here and throughout this whole process is that just because a data point has been identified as an outlier in this analysis does not mean that that number is wrong or that the harvesting is broken. We just like to use this investigation as a starting point to verify that that data is being pulled correctly. So in our Credo search case, I might want to go check and compare the data for that month to the reports from the vendor. And then I can tell if something happened on our automatic sushi harvesting or whether the vendor genuinely experienced higher usage. So that really wraps up the process for manually identifying outliers. And one final step of this process that's kind of stepping away from that outlier idea and that method is dealing with those vendors that have no data for the time period. So as you can see in this example, there are zeros going down the counter column showing no usage for Allen Press. And obviously there's going to be no outliers identified with that. So the final step to maintaining our sushi accounts is to find these databases that seem to not be pulling any data at all and also investigate those. And that's a very separate process than identifying outliers. What I do for this is a bit easier, and it's just pull the entire sheet into a pivot table, list out your vendors in your rows, and then have the sum of the usage data as columns. And if any appear as 0, that means no data was pulled, and I definitely want to investigate those sushi connections as well. So now that wraps up the whole process. And And next, I'm going to talk quickly about some maintenance and some further use of this sheet as well. So the reason I set up this sheet this way in the first place was so that it could be replicated. So as long as you keep the first few columns the same, the area shown in blue here, then you'll be able to use the same functions and just copy, paste, and drag them down for the new data you pull in Alma. And this process is made very easy when you're pulling an already made report from Alma, thanks to Marie, because again, those first few columns will always remain the same. So the only real setup for this process is the very first time you create the report and then write out all the functions in Excel. And it makes my day a lot easier when I have to find these inconsistencies, because after this initial time, I think it takes me about 3 minutes to get to the final outlier. And most of that is exporting the data, because again, I just take it, copy, paste my functions, put them down, and boom, there's an outlier. And then another option that I wanted to talk about, because I'm a huge data geek, is a little bit extra, but pulling all of your data into Tableau to visualize it. We did this here with the same data. You can see this is Credo search. This is our outlier at 121 in August, same as the data we were looking at before. And I find that Tableau can be a simpler option because it can tap directly into Ex Libris Alma Analytics through a web connection. And I know a lot of library service platforms have instructions also on how to connect data through an API or a web connection. And that's basically instantaneous. But I love data visualizations because this is just a small snippet of the dashboard. It shows so much different data. We're highlighting Credo search here, but it can functionally use to highlight outliers even faster than the Excel sheet. And it's also a really good way to show data to less data savvy people. And in this case, it's a bit extra because Marie and I are just using these outliers for our own personal use so that we can go identify platforms that need investigating. But if you're sharing data, which again, this has not happened with this data yet, it's very useful. And then my final topic I want to discuss is why I pulled the data out of Alma and into Excel or Tableau. And it's just because that is what I'm most comfortable with. And I find at the end of the day, doing things that are comfortable to you and make sense to you is time better spent than spending double the time in another software. And your library service platform might have different functionality, or you may be more comfortable using Alma Analytics for these custom calculations, and that's super awesome. The steps above should statistically translate into any analytic platform, but just because I find it more intuitive and easier to use, I got spoiled on Tableau and Excel through the years. So again, that's why I chose to pull it out. But again, the statistics really should translate into any analytic platform. Well, that really wraps it up for today. We really appreciate you taking the time to listen to our presentation on SUSHI data maintenance and some fun statistics. Are there any questions?
Thank you both for that. That was really good. We do have some questions in our Q&A, and if anyone has any more questions, just add them to the Q&A as well. The first one I see is, do you have your report templates in the share folders for other Ex Libris customers?
Thank you for asking. We don't have them right now. However, I worked on a presentation for this last year with a cataloger, Miriam Nauenberg at the University of West Georgia, and that presentation is available online. I'll drop the link in the chat. And we were recently approached by Ex Libris on using our report templates as templates for the community zone, which I am really excited about because they're very, very detailed. So I think y'all will like those.
That is exciting. Thank you. The next question is, how often do you run these reports?
Well, this year we ran them just before that I was going to pull all that data for our ACO statistics, and that's really the only time we had to run them this year. Was just at the the last minute, like, oh, we got to do this. Okay, let's put it on the schedule and get that done?
I think optimally, we'd like to do this at least once a year, but twice a year might even be a goal because we want to keep these sushi harvesting accounts up and running throughout the year.
Okay, thank you. How often would you say that the standard deviation-based investigation leads you to re-ingest data to fix an error?
Typically, I find that it depends on when we pull it. There was one time there was an issue with a few of our sushi accounts where it was counting the data twice in the harvesting. So once we fixed that and it didn't happen again, the next round I did it, there were quite a few less errors, but I would say a handful. It doesn't identify that many errors in the first place. It's quite often that a lot of the platforms have no outliers, so we don't investigate them, but the ones that do, I would say 50% would need a quick fix in their sushi harvesting account.
Okay, thank you. Is there a way to combine the sushi stats with stats from SpringShare and LibGuides?
We have not tried that yet.
Yeah, we definitely have not done that, but I could see the possibility if you're using a dashboard, especially of putting the two side by side. I am not aware of a good way to join those data sets.